I learn best if I know like what lies ahead, like what should I be paying attention to, like where are we going, right? So I do always take a little bit of, especially on a Monday, I kind of. So we did conversions, right? We did that, and then we started to look at surface area and volume of the most common shapes. We're not quite done yet with that, okay? And after that, we're gonna have composite shapes. So you should all recognize that, right? So for example, you have a cylinder, and there's a half a sphere, a hemisphere stacked on top of it, and maybe a cone at the bottom, right? So we have various shapes that we need to find a surface area and volume for. So that's where you need to understand how the formulas work out, because when you find surface area, right, this here and this here would not be included, right? We almost omit things where shapes touch, that face is omitted. So you have to kind of be careful there. And then ultimately, I'm already going to throw in some word problems here and there, like what if, right? And then ultimately, the final step would be let's calculate the cost of a project. So let's say you're digging a pool, and you're going to see this one, right? And so you obviously have to dig out this part. Okay, sorry, my art skills aren't the best. And then you're going to also pour a concrete pad around this pool, right? And that's only going to go a certain depth, right? So you kind of have that going on. Sorry. Right? So you have a certain depth to that concrete. So there'll be a lot of digging, a lot of filling it with gravel or soil or what have you. But as soon as you hear of a depth, something is like it's 3D, right? There's some 3D component to it. You will not be able to see this on the video, but from time to time I might use. Anybody use Tinkercad before? If you're in graphics or you do 3D printing or anything like that. So every once in a while I'm going to use this to help us see things. I don't know how often, but it makes it very easy to move stuff around and to see. It's like, okay, right here, right, they're touching right here, what's happening there. And so I will try to, I don't know. You know where I learned how to use Tinkercad is my oldest son, Daniel. He is in junior high and he's doing graphics, right? And they're doing 3D printing, and it's so cool. Like he showed me, like, this is what I'm learning in school. I'm like, wait a minute, I want to learn too. Show me a few tricks. And so I'm learning from junior high students, right? So it's pretty cool. Anyways, let's jump back in here. So we looked at a square base pyramid, not to be confused with a rectangular base pyramid, right? I think it is safe to say that 99% of the time, the pyramids will have a square base, okay? So I'm going to kind of focus on the square base pyramid. They're easier to work with. And so we came up with our volume, right? Two different versions. And anything that has a slanted face, like a cone and a pyramid, you will need to use Pythagorean theorem from time to time, okay? So let me see here. I have my original here, my key, so to speak, and I want to make sure we get this right. Okay, so if you're looking at this triangle right here, it's basically a cutout from this pyramid. Like if you cut this section out here, I kind of bring it out here. So this leg right here would be the height of the cone or the pyramid. So you can write down the height. And the hypotenuse in that sense would be the slant. That is the slant height. It's very important to know that there's a distinction between the height of the shape and the actual slant height, which is along the face of the shape. So hypotenuse, in a sense, this is the one you're going to use to find your slant height. So I go slant is equal to I will call this leg right here is basically A divided by 2. And you're like, wait a minute, why is it A divided by 2? It's Monday, Mr. Dixon, I'm still sleeping. Okay. Well, go up to this one, way at the top here, right? One of the sides of this pyramid is A. So if you just want to know this stretch right here, right? This stretch right here is A divided by 2, is half of it, right? So that's why I call this leg right here A divided by 2. So the slant height will be found by taking the side of the pyramid, dividing it by 2, then squaring it, plus the height squared. Okay. Should I write down height? I will do that. Sorry, guys. Be comfortable using an eraser with me. Right? So A divided by 2, height squared. And I think I'm going to do this. Right? So you're basically taking both legs and you're squaring them and then adding them. Okay? Okay. Next, if you want to know this leg in particular, which is the height, you would go the following manner. You go height. To find the height of this thing, you take the hypotenuse. The hypotenuse in this case is the slant. Okay, I'm just going to call it slant squared minus the leg squared. So it's this leg over here, which is A divided by 2 squared. And I'm going to give slant a different color. So you see it here. And the green one, I'm going to keep green. So there it is. I will probably box these in because I told you boxed in formulas are very important. I will tell you this. It's the exact same thing for a cone. Okay. This is the exact same thing for a cone. And there you have it. Okay. So slant you will need for surface areas. The actual height you need for volume. Okay. So it depends on the situation. You might have to use this one or that one. Depends on what you are given. Okay. So let's do an example right here. Determine the surface area, lateral surface area, and the volume of the following pyramid. So let's find the surface area first. That's A squared. I strongly encourage you to write out the formula. A squared times plus 2 times A times slant. Okay. Let me just focus that a little bit. Okay. So surface area is A squared. So that's 45 squared plus 2 times 45 times slant. The slant is given, folks. It's already given to us. It's 40 centimeters. So I'm just going to go ahead and plug that in. So in this case, it's just plug and go, right? And I'm fairly confident that you can just figure this out. Just typing it in all in one shot, you get 5625 centimeters what? Surface area, squared units, okay? It's been a while, right? The summer kind of makes us forget some of these things. So there we go. There we have the surface area. And I will do right next to it the lateral surface area. I don't know if you remember, lateral surface area just means get rid of the base, like top and bottom, if there is such a thing. In this case, there's only a base, right? So it's basically just 2 times A times S. Okay, this is A, and slant is given. So it's basically just this portion of the formula. And I will just give you that. That's 3600. So squared centimeters. So far, this should not surprise you. You've seen this before, okay? So, and there are no decimals to worry about. I'm going to kind of just close that to separate my work. And here I am with the volume now. With the volume, it's a squared times height divided by 3. Okay. I need the height, correct? I need the height going straight down the center. So if I go back to my formulas, I will apply this one right here. And how about we just call this A, right? This is just to make sure that's A, this is S. So to find the height, I will just follow my formula on my study sheet. I take the slant, square it, minus, that's very important, you're subtracting, A divided by 2, right? Squared. So 45 divided by 2 squared. And you're like, why don't you just put down 22.5? You can if you want. I just want you to see that I'm dividing it by 2. And here's where I will actually have my calculator show up on the screen, because sometimes using these new ones, it might be a little bit of a challenge. So I'm going to go 40 squared minus, watch this, you have brackets, right? So you can just go 45 divided by 2, I square that, and you get this. You can write down the whole thing. No dot dot required, right? So that's a square root. You can leave it in the root if you'd like, or square rooting. Have we done square rooting? I'm not sure, but watch up here on the screen. I just go second, and then you press X squared. This button right here where my pencil is hovering, there's a square root right above it. So square root, you can't just hit enter because it will give you an error. Watch. And you need to give it something. So I will press 2, go to. It kind of shows you what it doesn't like, that there's nothing in there. So let's see if we go up arrow. I'm going to copy that previous answer into it, then hit enter. So it's 33.07, and I will go dot dot dot, right? That's key for I'm going to use all decimals, right? And my unit is we're in centimeters, and now I can go ahead and find the volume, and that is 45 squared times the height, and that's divided by 3. And if you are careful with your calculator, right, you just go 45 squared times, I'm going to copy my previous answer, right? Copy that right in there. I hit enter at that point, and my last step will be divided by 3. Don't forget to divide it by 3. I can't tell you how often students forget to divide by 3. And we are in what units? Cube, right? Cubic units. So there's my volume for that square base pyramid. So in this case, I had to use Pythagorean theorem to figure out the height. It could have been a scenario where they give you the height, you have to find the slant. So deciding which one of these two versions to pick is important. Okay. We're okay? I think you are. You're just a little quiet. It's okay. So when there's extras like this, just leave it for now. I may come back and say, hey, write this example down. I'm going to skip rectangular pyramid. I just put that in there. If time allows, I will do that as well. But we're going to go straight to cylinder. I don't know why, but cylinder is one of my favorite shapes. Maybe because it reminds me of a pulp can. Maybe that's why. Anyways, surface area, if you think about it, area of top, area of bottom, area of side. So I actually want you to do this, right? Pi r squared plus pi r squared plus the area of the side is 2 pi rh, right? 2 pi r, if you remember, is the circumference of the circle. So the circumference times the height. And it basically gives you a rectangle, right? If you were to take that apart, it's a rectangle. So 2 pi rh is how you find that area. So if you combine the pi r squares, you get 2 pi r squared plus 2 pi rh. I'm going to box that in. If it's asking you for lateral surface area, it's basically a pipe where the top and bottom are not there. It's a hollow. You would just omit the 2 pi r squared part, and it's just 2 pi rh. I will say no top and no bottom. Right? In case you're, if it's a cup, obviously a cup would have one end closed, so you would have to know the variation there. It would just be pi r squared plus 2 pi rh, right? If it's a cup. So careful there. The volume, what's by definition the volume of a prism? Area of the base times height. So the area of the base is, I will do this, area of base times height. The area of the base is pi r squared times height. So that's why, and it probably will help you sometimes when you forget a formula. It's like, oh yeah, I remember area of base times height. Yeah, go ahead. All right, next. Let's do just some basic calculations here. Determine the surface area, lateral surface area, and volume of the following cylinder. Surface area is just 2 pi r squared plus 2 pi rh. So that would be 2 pi. So I'm going to go a little faster here. I need the radius. We're given the diameter. Radius is just half of the diameter. That's 42.5 millimeters. So I'm going to plug that in right away. 42.5 plus 2 pi radius. And the height is 287. Watch for units. In this case, everything is in millimeters. Good to go. No conversions necessary. I forgot to square this, guys. Can you make sure you add that? It's 42.5 squared. I will just give you the answers here. This is 11,349.003 ... That means I use all decimals. So I actually, when I do these, I tend to do them separately. And because it's so easy to copy and paste. Oh. The diameter divided by 2 is not 42.5, 42, that's 5. That's 85. 47.5, right? Yeah. Is it Monday? Sorry. Good thing I have students paying attention. Thank you, Jean-Marco. So that means that I have to change this. Yep, hold on. 2 times pi. No, what did I do there? 2 times pi times 47.5 squared. That's 14,000. Sorry, guys. Four, 3, 6. Everybody's mumbling. It's like, why? So that's 2 times pi times 47.5 times 287. So that makes that number And it's recorded, right? This mistake is now recorded. And just keep going like that. And my final step is then I'm just going to copy the numbers, right? That number plus the previous number. And so my surface area is 99,831.96. And I am in millimeters squared. It's asking for lateral surface area as well. So this is actually very easy to answer, because if you remember, this part right here gives me the lateral surface area. So I'm just going to copy that number, 85,655.52 millimeters squared. So let me use it to teach you, to show you what would happen if that happened to you, right? If you show me the work up here, it would only be a half mark deduction, because I clearly understand it was just a glitch. So if you show me a little bit of work, it saves you marks. If it's not there, if you just come up with a number there, then we have to take a full mark off because we don't know what happened there, right? So that's where showing your work is important. Volume. It's pi r squared times h times height, right? Pi 47.5 squared times the height, which is 287. And I have to redo this. So it's 2,034,318.69, and we are in millimeters cubed, right? We're doing volume. And let's add a little, I hope you still have a little bit of room there. If water weighs 0.009 grams per millimeters cube, right? Determine the weight of the cylinder. So let's say now it's asking you, it could have asked you that straight from the get-go. And when you realize, okay, it's something per millimeters cubed, right? Oh, I need to figure out the volume to figure that out. So there's a couple of ways you can do that. I will do it this way. I start with this fact, and then I just put it on the other. So this proportional reasoning, right? I have this many millimeters, and I will find how many grams that is. It's supposed to be grams. There. By the way, this millimeter cubed is 1, right? The coefficient there is 1 millimeters cubed. Did I show you the trick with cross multiplying and dividing? You may have forgotten, okay? So you go to the side where there's a variable, right? And then you start with a number, so you multiply up, and then you divide going down. Okay, so it's basically this. The kicker is you have to show me this step, right? So this times that, which most of you probably would have done anyways, and then divide it by 1, which is, I know it's irrelevant, but this number could down the road not be a 1. You still have to follow the steps. And the beauty of this calculator is that I still have that number, this one here. I'm just going to copy it and multiply it by 0.00918 308.87 grams. So a little bit of converting there at the same time. Pause a little bit. It could be that they give you, or right, give you this shape, but I tell you that it's only filled up to about 50 millimeters, right? So you have to think, it's like, okay, so this thing isn't full. When you figure out the volume of the cylinder, it's like a solid. You're figuring out the solid, like how much would it take to fill this in. But if I throw a curveball in that you're only filling it up to the 50 millimeter mark, you almost have to redo the volume, not using this as your height, but you would then use, right, the fill height, right, to figure out the weight of this partially filled cup or cylinder. Okay, so you gotta watch out for that. Next, two more shapes. Your cone. And a cone is it's a cousin of a cylinder. That's why I do them back to back. So the surface area would be area of the bottom plus area of the side. Area of the bottom is obviously a circle. And the area of the side, right, it's pi rs. Pi times the radius times the slant. Right? So if you want to put dots in between. Okay. And I don't know why I have another surface area there, but let's just box this in. We're going to just not worry about that. Lateral surface area, so no bottom, right? Or no base. So that would just be the pi rs piece. Sorry, pi rs. And the volume of a cone it looks very similar to a cylinder, right? Area of base times height, but you can clearly tell that this doesn't, right? You don't fill in the top with the same base with a circle, so you have to divide it by 3. So I'm going to do this version, or if perhaps like if you're maybe maybe you had a different teacher, right? May have used this version of it. Both do the exact same thing. Okay? So there's nothing wrong with using one over the other. Determine the surface area, lateral surface area, and volume of the following cone. You notice that, I hope you notice right off the bat, I give you the slant is in meters, and the diameter, right, is in centimeters. So watch for units, right? Okay, so you choose, if it's not asking you to state it in a certain unit, you choose. I'll probably just turn this into meters, or, right, like it's up to you what you want to do there, but this is really 15 meters. Okay, let's divide it by 100. And now we have everything in the same units. So surface area is pi r squared plus pi rs. It's pi. Am I going to get my diameter right? My radius, sorry. The radius would be 15 divided by 2, which is 7.5 meters. Am I good? Okay, whew. Don't want to get that wrong. 7.5 squared plus pi r, and the slant is 10 meters. Okay. It's 235.619. So the surface area, you just copy and paste. Right, 412.33 meters squared meters, okay? And the lateral surface area is just pi RS, which is pi times 7.5 times 10. And I'm just going to steal the answer from next door here, 235.62 square meters. Okay. So this would be a cup, you know those paper cups you get from time to time, right? Bathrooms or whatever, going to drink of water. If it's asking for how much paper is needed to make this cup, you would use this one, right? You would not want to include that circle at the top. Okay. The volume, how much water could be fit into this cup, right? So you go pi radius squared times the height. You need to find the height. So I'm going to take this chance. Sorry, I'm moving back and forth here. I'm going to take this chance, right? This would be the height. This part right here is the height. This is your slant. And this, in this case, this would be the radius, right? So this is 7.5. So if you want to go back, I'm going to quickly find, so I'm going to kind of do this. I'm going to, on the side here, find the height. The height is my slant. I think I'm rushing a little bit here. I want you to have a note, right? I will go slant squared minus, I can go radius squared actually. This, and when you're talking a cone, this is the radius, right? So I'm going to put an R there. So then the slant is 10 squared minus the radius, which is 7.5 squared. And so that would be 100 minus 7.5 squared. That's 43.75 if you take the square root of that. And I hear a lot of clicking. That's good. Especially after that mistake I made, right? You better stay alert, okay? So it's pi r squared times the height, right? This is 6.614. I keep going. Oh, let's make sure I dropped the 3 here. It's very important not to do that. Okay? I dropped the 3, so don't forget that. So I'm going to go ahead and type that in. So pi times 7.5 squared times, I'm going to go copy my previous answer. I'm going to hit enter at that point and then divide by 3. That's 389.62. And it's meters cubed, okay? And that's just, I just highlighted the fact that you first, and look at the marks. If it's just a 1 mark question, it's usually just plug and go. If it's 2 marks, right, if you see the marks being higher for that question, and obviously this would give you an extra mark, okay? And last but not least, the sphere, okay? Spheres are pretty easy to work with because really all that you need is the radius, right? If you know the radius of a sphere or hemisphere, you're in business. You can find volume and surface area. So they're actually fairly simple to work with. Okay, so the surface area, anybody know the surface area of a sphere? Sorry? Pi r squared, close. There's something that goes before the pi r squared. Anybody? No? That's okay. 4 pi r squared. Why would you know that, right, if you're never using it in real life, right? The volume is 4 pi r cubed, very important, right, divided by 3. So those are the only two formulas you need for a sphere. What about a hemisphere? Hemisphere, right, is a half of a sphere basically. So if you just want the surface area of the curved part, like this part right here, right? If you just want that surface area of like the outside of that bowl, right, then it's obviously just half of the previous, right? So it's 2 pi r squared. That's it. But if you also want, if you're assuming that this space is filled, right? So let's say this is a solid and you want to find the surface area of it, you would have to find the curved piece, right? Like everything around it, as well as this one circle at the center, right? So that would be pi r squared plus 2 pi r squared. And you're like, why is he doing that? Pi r squared is this. And the 2 pi r squared, you guessed it, is that outside part, right? So there's two pieces to it. So that basically means that it's how many pi r squared? 3, right? Tres. If you know your Spanish, right? I don't know. I don't know what to call this. SA including base. There it is. It's 3 pi r squared. And then the volume kind of gets pushed aside there. So I'm going to either just scratch the volume there, give me some space there. The volume would be half of what the volume used to be. You're like, whoa, I need to do that. Well, that's basically, in a sense, what you would be doing. You would just split it in half, but you go like this. Guys, when you have things like fractions multiplying, everything is being multiplied, there's no plus or minus anywhere. You get to go and see, oh, these are both even. 2 goes into this how many times? 1 time. 2 goes into this 2 times. Like I basically divided both of them in half, and you're simplifying a fraction. More about this later. Don't panic too much if this is now throwing you off. As long as you, for now, remember that this is the formula for a hemisphere. This is a hemisphere, guys, so make sure you get that right. Some students write that down. It's like, oh, this is for a sphere. No, it's a hemisphere. All right. I think here what I need you to pay attention to is how I do it, like the steps required, not necessarily the final answer. Because I know a lot of you are really good at click, 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 click. Yeah, this makes sense. Boom, answer, right? So make sure you show your steps. That's what's important about these types of questions, okay? So, go ahead. I will just highlight things, right? The volume is given to me. I have length of 12 millimeters and height of 9 millimeters, right? They want the width of the box. That's the question. So what I mean by working backwards is that you're going to have to do reverse operations to figure out what's missing, okay? So can I encourage you to start with a formula in question? So this, the volume is what tells you what you start with. Like the fact that they're giving you volume or surface area or whatever is that your starting point. And I know that for a box, it's length times width times height. And so let's plug in what we know. The 470 goes on the left side. The length is 12. I'm going to put that in brackets. My width is unknown, and the height is 9. So everybody at this point should be like, yeah, I get what's happening there. I'm going to do this a little bit faster, though. The only thing that's happening on the right side is multiplication. So watch what I'm going to do here. If you have a different color, it might come in handy. So I'm going to go, I want to divide this side by 12 to cancel out the 12, and I also want to divide this side by 9. I'm going to do the same thing to the other side. 12 and 9. I have to do the same thing to both sides. So here you cancel out, right? Cancel, 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 cancel. Some teachers will say it's not canceling. It's really 1. 9 divided by 9 is 1. 12 divided by 12 is 1. So there's just the 2 ones that we omit, like we don't think of them anymore, but I like to use cancel, okay? Watch this though. To find W, now you've isolated W successfully. On this side, you have to be very careful, okay? What is the denominator doing? Multiplying. I will tell you that whenever there's an operation in the denominator, adding, multiplying, whatever is happening, that needs to happen first before you divide the fraction. Does that make sense? So I'm going to do this. Watch my calculator carefully. 470 divided by brackets, guys. I'm going to go bracket 12 times 9, like that. So I'm saying 470 divided by whatever is happening in the denominator. So you need to do it like this to get the right answer. Does that make sense? So that's 4.35. What are my units in? I check, it's in millimeters. So this is my answer. Boom. So that's an easier example. So let's step up the game here. The volume of a cone. So that's everything is important there. It's the volume, and we're talking about a cone. The height is this. Determine the radius. Okay. So volume of a cone. I start with a formula. Pi r squared times h. Uh-oh, this is the one we don't like. Divided by 3. But that's okay. We'll work with it. We know what the volume is. That's 26. Plug it in. Pi radius squared. I don't know what radius is, so I just need to leave it like that. And I do know the height, which is 6.5. I'm going to put that in brackets. Divided by 3. Don't forget about divided by 3. What would you do first? What would you try to get rid of first? Francis? Timesing it by 3. I would get rid of that 3 for sure. So that's my first order of business. Times it by 3 or multiply it by 3. I like to use a different color so I show what happened, right? So on this side, all you're doing is canceling. On the left side, you're actually multiplying. So 3 times 26 is 78. And then I'm left with pi r squared times 6.5. And now, guys, I call this a one-liner. It's basically the same thing as we had on the first example. So I'm going to do this. Watch. Pi is just really a number. So I'm going to divide both sides by pi. And I'm going to divide both sides by 6.5. Which means I need to do the same thing on the other side. Let me move that up a bit. 6.5 cancel, cancel. Pi, pi, cancel, cancel. Watch this. I'm going to continue my work up here. So I like to kind of just show where my train is going. So I'm left with what on the right side? Radius squared. Okay. And on the left side, well, that's just a matter of using my calculator. Okay, so 78 divided by, careful, brackets, right? Pi times 6.5. So that's 3.819, and I'm not going to round just yet. Dot, dot, dot is the way to go. And you know what happens next. What needs to happen now to get radius? Square root, right? Square root both sides. So radius, and then you just grab your calculator, you go second x2, copy the previous answer, paste it in there, hit enter. 1.95 is my final answer. So this was a little bit more time consuming, right? Now I want to do a surface area. So let's do question 3 there. And I think that's going to be it for this section, okay? I might come back to the other ones later on as time allows. The lateral surface area of a cylinder is that. So very important. The wording is so important here. Determine the height, right, if the radius is this. Everything is in inches, no conversions needed. And you're like, well, it's squared units and then single, right? That's okay because this is the surface area we're talking about. Lateral surface area of a cylinder is, I'm going to go check my study sheet, and I will know that it's 2 pi RH. I plug in the 870. 2 pi R is 19.5. H is unknown. So it's not too bad, right? I just need to divide. This is a one-liner, so I don't need to worry about any denominator here, any 3, right? So here what I do is I'm going to go 2 pi times 19.5. I want to get rid of all of this. Okay, same thing on that side. 2 pi 19.5. Can I just say something here? Just so you know, if you type in 2 times pi times this, you get one big number. So you're basically dividing that big number by itself, right? So let's see, 2 pi, cancel, cancel. And then on the other side, you just go 2 times pi times 19.5. 7.10, right? 7.1. And I hope you're okay. A lot of us are so used to it's always h is equal to that, right? We don't like to have it flipped on us, but it's the same thing. Yeah. Are you allowed to just flip it around so it looks neater? Sure. Yeah, but you're saying the same thing, right? My bank account has $7. There are $7 in my bank account. Same thing, right? That's what you have in there. All right. So this is backwards. You will have a few of those in the assignment that I'm giving you, the homework. Let's keep going. We'll go past the extras, and then we go to page 13. Still with me, right? Page 13, about halfway, and you're like, why are there so many blanks? Because when I make these booklets, I want to allow for extras if I ever have something extra to add, right? Sometimes it comes to me later and to help you out, right? Solving problems involving composite shapes, hollow shapes, etc. Okay, so now we're gonna really get into what's gonna get us ready for the word problems. Now that we've reviewed and derived formulas for the most common shapes, we can use that to determine surface area and volumes of complex shapes, right? Complex or composite. Important steps to include. Write down all the sides you need to include and which need to be subtracted or omitted, right? So it's important to know that we're going to have to subtract sides from time to time, you will see. Use abbreviations if needed. Include all shapes, right? Start to write down the formulas required. Include formulas for faces to be subtracted, right? That is very important. If you choose to solve everything separately, do not round too soon. Okay? Which, quite frankly, those of you who had the old calculators last year with me, you're like, this would have been painful, but now that you have the new upgraded calculators, it makes it very easy, right? To just go and copy what you did 3, 4, 5 steps ago, right? Make sure that you check if answers make sense. When multiple shapes connect, do not include that portion, okay? So let's go and do this together. This is like the meat and potatoes. Ideally would have been here by now already, but with the staggered start of the school year, it all, and lockers, I may add. Are you happy about lockers? Yeah? Okay. All right, composite shapes. A company needs to produce cardboard boxes as depicted below. Calculate the amount of cardboard needed. Cardboard needed. Okay? Very important. That should tell you that this is probably I'm gonna figure out how much surface area, what the surface area is to make this, to cover this, right? And B, what would the capacity be of the box? Like how much would fit in it? So I need you to understand that this question could have been just mentioning this, right? How much would fit in it? Like what is the capacity of it? And if it costs, I'm going to add that later, okay? I didn't know what I wanted to do with that question. I think I wanted to turn it into a word problem, and I forgot to finish that sentence. You're the first group getting this booklet, okay? So it might be a little rough on the edges, but at least you don't have to write down all these diagrams and whatnot. Okay, so let's figure out the surface area first. What I want you to do is right off the bat is these two shapes, they connect right here. So this here is not to be included. So you have to look at it. You're going to first deal with a cylinder. Don't include the circle. Then you're going to deal with that box. Don't include the circle, right? So keep that in mind. Omit circle, okay? You need to omit that. So let's see here. Surface area. I'm going to call this TSA. And it stands for total surface area. Okay. I'm going to do a few things up here. I'm going to tell myself that the radius of this is going to be 1.5 inches, right? Then I have it ready to go. I don't need to worry about that. And it's probably a good habit to go like this. I'm going to figure out the surface area of the cylinder without bottom, plus I'm going to find the surface area of the box, right, without circle. And some of you are going to be really good at making this nice and clean and maybe use fewer lines than me or more lines than me. I really don't care as long as you arrive to your answer and you show me the steps, okay? So here we go. Surface area of that cylinder there, I'm going to go pi r squared, just pi r squared, not 2 pi r squared, right? Plus 2 pi rh. And I'm going to do this. I like to kind of square bracket that because that takes care of that first part. Plus, do you remember what the surface area is of a box? 2 times, we'll go length, width, height. If that helps you, I'll do that on that. Right? So 2 times length times width plus 2 times length times height. I guess I'm going to do brackets like that. Plus 2 times width times height. So if you ever forget, it's length and width, they multiply, that's your top and bottom. And then the length multiplies the height, and the width multiplies the height. Those are your sides, your walls. Okay? What do I need to do to this part right here? Like, because if you plug in this whole thing, it's the entire box, right? This entire face at the top here. But we don't want to include that circle when we're looking at the box. So I'm going to go minus pi r squared. And if you want to just make an arrow, you're getting rid of that circle. And you're like, what about here, Mr. Dirksen? I got rid of the 2 here. If you want to do that, if you want to do this, and then just turn that into 1, right? Because we got rid of that 1 circle by just turning that 2 into a 1. Okay, so we took care of that circle for both of them. And now we can go ahead and just plug in pi r squared plus 2 pi r times h, which is 20. I like to have it like this. Plus 2 times length times width plus 2 times length times height plus 2 times width times height minus pi r squared. Does anybody see the pi r squares happening twice? Do you see this pi r squared here? And then there's a minus pi r squared there. Overall, what they're going to cancel out, right? It's like plus 1 minus 1. So if you like to cancel them right now, you go for it. And I'm actually going to cancel them right now. Okay, so this one cancels with this one. If you happen to see that, if you don't, just type it in. Just type it in and you'll still get the right answer. But it just makes things easier. So here is my 2 times pi, if you want to follow, because you never know with Mr. Dirksen, it's just unpredictable. Plus, this would be 12 times 10 is 120, plus 40, plus 80. Oh, why did I put h here? Sorry guys, this is supposed to be a 4. So that's 248. So I'm going to go just add them up. It's easier to just, so 436.50. 436.50. And we are in inches, squared inches. Oh, wait. I'm just double checking this part because yeah, we're good. So that's the total surface area of the shape. And so I'm going to cut this here. We're almost there, guys. We can do this. And then the volume would be volume of cylinder plus volume of box. Do I need to worry about the sides touching the circle when it comes to volume? The answer is no, because volume is not concerned with things touching. It's just like filling up, right? Like we're just filling those containers, or we're finding how much space is inside. So we're just going to go pi r squared h plus length times width times height, like that. I'm going to continue up here. I'm going to call this TV, total volume. It's not just the volume of this, volume of that, it's the total volume. So total volume is pi r squared times the height, which is 20, plus, we can do square brackets, right, to kind of, and then it's length times width times height. Does anybody have the answer to that already? No? I'm going to split this into 371 ... and this is simply 24 times 10, so 240. So that's 381.37, and we are in inches what? Cube. Okay. So there you have the volume and the, and I'm just going to omit C there on the top because we're not going to have room to fit that in. So just, you can just scratch C and not worry about that. The next one is going to take me longer than 5 minutes. So what I'm going to do here is, if you, at the bottom of this page, just write down the homework. You got handouts. You should all have received a handout. It says design and measurement warm up. Just to give you a heads up, I made a bigger booklet with all the worksheets that you could possibly get. And I had to print the first 3 because they're so behind in the central print service. So when you get that booklet, these are going to be in there again. So then I apologize for that. But I'm trying to also give you enough space here to work through it. So I'm just going to say pages 2 to 4. Actually 2 to 5. Pages 2 to 5 in the worksheet, right? Warm up worksheet. And I will post the answer key to that later today. Okay.